Hi everyone, welcome to the tutorial on carbapenemase. So this is following our tutorial on ESBL AMC. In this one, we are going to discuss about carbapenemase. So first bit of introduction about CP, CPO, CRO, CRE, different type of terms. And then we'll talk about chromosomal and plasmid in terms of CPE. We will discuss about big five carbapenemase producing organisms, how to find CP, so the screening and confirmation of the carbapenemase producing enterobacteriales mainly, and then treatment. I will direct you where to look for, and then we'll go through some antibiogram analysis to find out how you can detect a carbapenemase or an ESBL or a combination of mechanism, etc. So first, let me explain a few terms. CP, CRE, CRO, and CPO. There are various type of terms that you will encounter in clinical practice and in the exam and in various settings. So just to explain these terms, E here means enterobacterialis. So when it says carbapenemase producing enterobacterialis, are those enterobacterialis like E. coli, Klebsiella, Enterobacter, which are capability of producing carbapenemase enzyme. Term CRE means carbapenemase resistant enterobacterialis. So these are enterobacterialis which are carbapenem resistant, but not necessarily because of carbapenemase. There might be other mechanism which is making them resistant to carbapenems. Then you will find carbapenemase resistant organism and carbapenemase producing organism. So these are not only enterobacterialis, these are also non-fermenters. So for example, Stenotrophomonas, it will be a carbapenemase resistant organism, a carbapenemase resistant organism, and also a carbapenemase producing organism, because Stenotrophomonas have L1, L2 carbapenemase that make it resistant to meropenem. So this is not an enterobacterialis, but this is a non-fermenter. So if you want to include enterobacterialis, Pseudomonas, Acinetobacter, Stenotrophomonas, all including in one umbrella, then that will be carbapenemase resistant organism and carbapenemase producing organism. Of course, producing ones are which are producing, and those which are carbapenemase resistant, but not necessarily producing carbapenemase. So to give you some example, here we take carbapenemase resistant organism, carbapenemase producing. So see these examples. Artapenem, as you know, is always Pseudomonas is always resistant to artapenem. So why? Is it because of carbapenemase? No. It's because artapenem is a large molecule, it's finding difficult to enter, and it also has an affinity for the efflux pump of Pseudomonas. So that's why when it's getting it gets kicked out quite quickly. So artapenem never works on Pseudomonas. You might occasionally find that isolated meropenem resistant Pseudomonas. These these will be like you find meropenem resistant E. coli, but it is sensitive to piptas and meropenem resistant Pseudomonas, but the Pseudomonas is sensitive to piptas and ceftazidime. So these are not because of a carbapenemase. This is because of an upregulated efflux pump. Similarly, you might find isolated imipenem resistance, which is because of operative porine loss. So operative porine loss preferentially affect imipenem. On the other hand, upregulation of efflux pump preferentially affect meropenem. But you may still find some degree of resistance in imipenem and meropenem in those cases. In case of Enterobacterialis, you might find carbapenem resistance not because of carbapenase, but when ESBL or AMC are combined with other mechanism like porine loss or upregulated efflux pump like that. So now we'll go into carbapenemase producing organism. So carbapenemase producing organism could be chromosomal. They might have chromosomal carbapenemase. The gene might reside in chromosome, or they might reside in plasmid. So there are certain carbapenemase which lives or resides in chromosome, like for example, in case of Stenotrophomonas L1 or an L2 carbapenemase, or in case of Aeromonas CPHA carbapenemase. So these are carbapenemase which are found in chromosome. But on the other hand, plasmid mediated carbapenemase are found in various organisms, Klebsiella, um, Enterobacterialis, Citrobacter, many of them. And these are like KPC, OXA48, like NDM, IMP, VIMP, etc. So these carbapenemases are the major problem because they can jump from one organism to other, and these are the carbapenemases we are worried about most of the time. So if you get a patient with KPC carbapenemase, you will going to isolate. But if you find a patient with a stenotrophomonas, although it's meropenem resistant, you might not isolate them. You might just kind of introduce some contact, like some hand hygiene and things, and then standard infection control precaution, and that should be sufficient. But you will not leave a KPC producing organism, infection with KPC producing organism in the open bay. You will isolate them in a single room. That's the importance. So the first carbapenemase was identified in Japan in 1991, which was an IMTIME, which was also a member of Big Five. And then the second one was KPC, that was in 1996. So in this slide, I will explain about the Big Five. So 1991 came IMP, 1996 in USA, KPC was discovered. 1999 VIM came in Italy, so that is like Verona. In Italy, the VIM was identified, and then 2004 OXA48 was found in Turkey, and then in 2008 NDM was found in India. So these are the big fives, which are the major problem worldwide, including UK. But these are not the only carbapenemases. There are various other carbapenemases, for example, this IMI, NMC, FRI, SME, CHES, etc., etc. So in classifying, when we classify carbapenemase, there are two types of classification: Booth-Jacobi and Ambler classification. I'm not going to the Booth-Jacobi classification because it's slightly difficult, and I will explain it in a different presentation. But in Ambler classification, the carbapenemase or beta-lactamase are divided into 4 groups. So one is Ambler class A, which is a serine beta-lactamase, Ambler class B, metallo-beta-lactamase, Ambler class C, serine beta-lactamase, and Ambler class D, serine beta-lactamase. Now, Ambler class C do not have any carbapenemase. That is only AMC. That is reserved. C is reserved for C. So there is no beta-lactamase, or there is no ESBL or carbapenemase in group C. It is only AMC. In here, the carbapenemase are found in class A, which is KPC, CHES, etc. Class B, which is NDM, VIM, IMP, etc. And then class D, which are OXA group of carbapenemase. So we find carbapenemase in 3 groups. Class B only have carbapenemase and no other beta-lactamase like ESBL or others. Class A has ESBL, broad beta-lactamase, carbapenemase, and so class D. So just to remember, the carbapenemase are in only class A, class B, and class D. There is no class C. So in terms of distribution, the class A carbapenemase are mostly found in Enterobacterialis. So E. coli, Klebsiella, Enterobacter, those organisms, and those are like KPC, as you know, KPC is common, is Klebsiella. Now, class B are found in Enterobacterialis, but also found in non-fermenters. So IMP, VIM, NDM, these are the member of Big Five. They are the class B metallo-beta-lactamase, and they found in Enterobacterialis and also on non-fermenters. Class D is mainly found, class D OXA48 like enzyme is mainly found in Enterobacterialis, but other OXAs can be found in non-fermenters, especially Acinetobacter. Detecting carbapenemase. So you might detect carbapenemase in 2 situations. One, when a patient is being admitted to the hospital, then UKHS suggests that we should be screening those certain group of patients for carbapenemase. So that's when you might find it might have to detect carbapenemase. And second is a clinical specimen. So like a blood culture, urine culture, fluid culture. When you find an organism which may look like a carbapenemase, you might need to take it through to see whether there is a carbapenemase there. In this group of patients who are being admitted to hospital, UKHS suggests that any patient who has been admitted to another hospital in last 1 year should be screened for carbapenemase. If the patient is being admitted to augmented care, they should be screened for carbapenemase. So this will be like critical care or SCABU. If patient has previously been positive for CPE or they are a contact of a CPE positive patient, they should be screened for carbapenemase as well. The method of screening is rectal swab typically, and most of the hospital in UK using PCR based method to identify carbapenemase. It's quicker and sensitive, but some of the laboratory may do culture or chromomegar or other methods. So mainly PCR is becoming the commonest method. The other situation is that when you are culturing something like, so for example, a blood culture or sputum culture or urine culture or wound culture, then you might find some organism which are meropenem resistant, and you might think, oh, could it be CPE? And you take it through and find out whether they are actually CPE. So it can be from any specimen. So these are the two situations when you might have to detect carbapenemase. So how do you screen for carbapenemase? So these are like specimen like blood culture, urine culture. How do you protect yourself from missing any carbapenemase? You screen using meropenem. This is from UCAST. So UCAST suggests that you can screen using ertapenem, which is very sensitive, so you might get some false positive result, or you can screen using meropenem. So typically we screen using meropenem. So this is important to remember that clinical breakpoint for meropenem is much higher than the screening breakpoint for meropenem. So this is from Klebsiella pneumoniae. Clinical breakpoint is 2 meropenem. So anything below 2 is sensitive, anything above 2 is resistant. But that is for meningitis, of course. Non-meningitis, it's even higher. It's like 8 here. Now, if you are screening for carbapenemase, the breakpoint is 0.125. So there is a large area where even if you're treating by meningitis standard, if you're taking by meningitis standard, this area, the organism might, the Klebsiella might look like a sensitive Klebsiella, but it still could be a carbapenemase producer. So if you find a Klebsiella is an meropenem MIC is 0.25, even though it is sensitive to meropenem, you might have to still check for carbapenemase. So this is a difficult concept, but you have to remember that. Once you have found that the screen is positive, that the organism is meropenem resistant, you need to confirm it. There are various methods of confirmation. Typically, we do PCR. So PCR test for the big five, which are the commonest type of carbapenemase in UK. But there are other type of carbapenemase is increasing, so you need to be very vigilant. And if you think that it still could be carbapenemase and PCR is negative, you have to say that you will send it to reference laboratory to test for other carbapenemase types. But there are other methods many other laboratory use. Like for example, some laboratory may use Carba-NP based method, which is a lateral flow device, immunochromatography assay. Some may use combination disc test, which used to be very common in few years back, but now PCR is kind of taking over, but many labs still use Roscoe disc or mass discs. Carbapenemase inactivation method is not used much because it cannot detect individual carbapenemase type. So is modified Hodge test, which is not recommended anymore because it cannot detect individual carbapenemase type. Then colorimetric test can be used, or you can use automated method like MALDI-TOF or BioFire that can detect carbapenemase as well. So once you find the screening positive, you go for one of the confirmatory tests. Typically, PCR is the commonest. But remember, you might not find all type of carbapenemase in your laboratory, and if you still suspect that it could be a carbapenemase, then you need to send it to reference laboratory for confirmation or detection of other type of carbapenemase. How do you treat? So this is taken from IDSA guideline, and I'm not going to go into the detail of it. You will find You will find it in Moodle, and you will find it in IDSA guideline as well. That how to treat when you find different type of carbapenemase or carbapenem resistance organism. So they divide the treatment into two parts. Once you find the organism is carbapenem resistant, then you use this chart. You see it's carbapenemase resistant enterobacteriaceae, it says here. So use this chart, and then they also say when you have detected type of carbapenemase, how do you treat it? So this chart actually tell you that when you have detected the type of carbapenemase, how would you treat? So KPC, you can use this combination, these antibiotics, meropenem vaborbactam or ceftazidime avibactam, imipenem relebactam, NDM, ceftazidime avibactam with aztreonam or cefiderocol, and oxa 48 ceftazidime avibactam. In the UK, for NDM or metallo-beta-lactamase, cefiderocol is licensed, and for others, ceftazidime-avibactam is licensed. But sometimes we might use ceftazidime-avibactam with aztreonam for this one as well. This chart is also in Moodle, and you will find it in internet in various places that what antibiotic cover which type of um, resistant mechanism. So you see that ceftazidime-avibactam cover. So NDM is particularly troublesome, and it is only covered by either aztreonam, which is often stable against NDM, and so aztreonam, avibactam, iravacycline, and cefiderocol. These are the organisms. This chart is also available in Moodle, so you can have a look, and you may probably need to know about it as well. Now we'll move to antibiogram analysis. So we are going to go through each set of antibiotic and see what information this antibiotic give us. So first one will be amoxicillin and coamoxiclav. So you might find this amoxicillin resistant and coamoxiclav sensitive. So in the exam or in clinical situation, you might find just resistant sensitive, or you might find MIC or zone size. So just look at that. If it's like amoxicillin MIC too large and coamoxiclav is small or resistant sensitive, this is most likely an ESBL, because ESBL can be inhibited by clavulanic acid. So this pattern is suggestive of ESBL, but also clavulanic acid can to some extent inhibit class A carbapenemase. So you need to say maybe. So this is probably ESBL, maybe class A, based on this information here. Then we'll go to three more antibiotics. These are piptaz, temocillin, and aztreonam. So piptaz, again, ESBL will be sensitive. Temocillin, aztreonam, you really cannot get much information from there because they are variable. They might be sensitive, they might be resistant. It will not help you. AMC, piptaz will be resistant, and other two antibiotic will be variable again. Class A, again, as similar to coamoxiclav, piptaz may be for class A, but other two antibiotic will be resistant. Class B, piptaz and temocillin will be resistant, but aztreonam will be sensitive. So class B are often unable to hydrolyze aztreonam, which is a property that can be used, but it is not always true. For example, NDM type 1, NDM1 can actually hydrolyze aztreonam. So it is not always true, but examiners have to give you some hint. So they might put it like aztreonam sensitive to tell you, think about NDM or think about class B. Class D is high level resistant to piptaz and high level resistant to temocillin. Which one is important? Perhaps temocillin, but you should pay attention to both of them. And aztreonam is variable. This is important. This is the one of the most important markers of class D. So what we'll do is we'll all take all this information and generate a chart here, which will help you to kind of decipher what kind of mechanism of resistance is there. So third group is cephalosporin. So ESBL is resistant to all cephalosporin, but not cefoxitin. So cefoxitin will be sensitive. AMC is resistant to all cephalosporin, but not cefepime. Cefepime will be sensitive. Class A, Class B, there is no issue there. It is resistant to all Class A, Class B. They confer resistant to all cephalosporin, but class D is a strange beast that it can show sensitive pattern to third generation cephalosporin, fourth generation cephalosporin, and even some cases like cefoxitin. So it can show some sensitive. So it is difficult looking at class D and cephalosporin. Are they carbapenemase? So we need to be a bit cautious, and you might need to rely on piptaz and temocillin high level resistant to detect it. So we put that into the chart. Synergy. This is important. This will help. So if you find third generation cephalosporin resistant, but third generation cephalosporin with clavulanic acid is sensitive, you know clavulanic acid can inhibit ESBL. So it is most likely an ESBL. It can be given with an MIC as well. There is a pattern you can see. So here, this pattern is important to understand. So pay attention. Third generation cephalosporin resistant, third generation cephalosporin with clavulanic acid resistant, fourth generation cephalosporin resistant, but fourth generation cephalosporin with clavulanic acid sensitive. What is going on here? So this is MC plus ESBL. So what is happening? Third generation cephalosporin resistant, it could be because of MC or ESBL. We do not know. But when you have put clavulanic acid, then it should be sensitive if it's an ESBL. But because MC is there, MC is not allowing it to be sensitive. Right. Cefepime would have been sensitive if it was MC only, but ESBL is breaking it down, so it is resistant. But when you use cefepime with clavulanic acid, there is clavulanic acid is inhibiting the ESBL and cefepime is inhibiting the MC, so you are finding it sensitive. So this pattern is MC plus ESBL, and in this case, you will find cefoxitin resistant. So cefoxitin resistant in the previous slide will be because of MC. So MC being there, it will make cefoxitin resistant. So this is the pattern, and also you remember that cloxacillin is the inhibitor of MC. So if you see similar synergy, which you have seen with clavulanic acid with cloxacillin, then you should think about MC. And also, if you remember, clavulanic acid may have some effect on class A. So if you see this effect, you might need to think about it could be class A as well, but you need to corroborate with other findings. So we'll put it in there. New cephalosporins. New cephalosporins are ceftolozane tazobactam and ceftazidime avibactam. This is heavily used in reference laboratory. So for testing. So ESBL and AMC is likely to be sensitive to these two, but ceftolozane tazobactam will be resistant for class A. Ceftazidime avibactam, it will be sensitive. Then class B, both will be resistant. Class D, both will be sensitive. So this pattern is important to remember when you go for antibiotic interpretation, antibiogram interpretation. We'll put it in there. The last but not least important, last but not least, is inhibitors. So they are often given, and it is an important information that you have to use again. Clavulanic acid you already know inhibit ESBL and may inhibit class A. Cloxacillin inhibit MC, and boronic acid inhibit MC and also class A. And EDTA inhibit class B, and dipicolinic acid inhibit class B. This is important to remember. So make your own mnemonics. You can remember by using this class A boronic acid, and MC ABC for boronic acid, and C for C, MC cloxa for cloxacillin for MC, and NDM, EDT, and dipicolinic acid all has a D, so it will be for class B. NDM is a class B metallo-beta-lactamase. So somehow you have to remember, you can make your own mnemonic, you can use this mnemonic, whichever helps you. We'll put this information there. Few more bits of information that might help. If you find only artapenem resistance among all carbapenemes, so say artapenem MIC is higher than meropenem, or artapenem is resistant and carbapenem is meropenem sensitive, you might think about porine loss is a potential mechanism. Selective hydrolysis of cefotaxime. So cefotaxime resistant but ceftazidime sensitive and is in ESBL, then you should think about CTXM type of ESBL. If you find selective hydrolysis of ceftazidime, you may think about SHB type. It's not always true, but at least it will help to some extent. The other one I have already explained when you find MC and ESBL together. So here we'll go through some resistance mechanism. I will explain here to you. So this one, you see, amoxicillin resistant, coamoxiclav, low synergy, so it is probably not ESBL. Piptase high level resistant, okay, it is not ESBL. It is not probably class A because you do not see anything here, but high level resistance is suggestive of OXA48, so there could be that. Now, cefotaxime is sensitive and ceftazidime is sensitive, and there is no synergy with clavulanic acid or cloxacillin. So if there is only one dilution, you need to be careful. It might not show synergy. It might be just reading. One dilution is not that important. So you need to be careful in interpreting one dilution. So here, cefotaxime and ceftazidime are sensitives, but we know that OXA48 can produce third generation cephalosporin sensitivity. So might be it's oxa. Cefepime is sensitive and cefepime clavulinic acid no synergy, so it's not an ESBL. It is probably not class A, uh, and so okay, let's move on. Cefoxitin resistance or not against ESBL. Timoxylin high level resistance, that's going for oxa. Aztreonam 12, we really do not know. Is it class A then? No, meropenem boronic acid, there is no synergy. So ABC boronic acid for class A, there is no synergy, so it is not class A. And there is no synergy with EDTA, so it is not class B. But their artapenem is higher than meropenem, so it could be a porine loss. So it could be but it is only one dilution so we are not really sure whether this is significant or not. So I would refrain from saying that it's a porine loss. I would just say it is an oxa based on piptas and timoxylin high level resistance and sensitivity to this. And there is no other resistant mechanism found on analysis. This one, amoxicillin resistance, coamoxiclav no synergy, piptas, that not that high level. So we really do not know. Cefotaxime quite high resistance, and there is cefotaxime clavulinic acid synergy. So it could be an ESBL, but we haven't seen any synergy here. So we really do not know. It could be a class A as well. Okay, if we think it is a class A, is there any boronic acid synergy? Yes, there is a boronic acid synergy, so it confirms that it could be a class A. Now, there is not much synergy there. So we have found that it could be a class A, and that has been confirmed by our inhibitor testing. And then we have given ceftolozane tazobactam and ceftriaxone avibactam. You remember that class A has resistant to this, class as sensitive to this. That is confirming that, so that's fine. Cefepime clavulinic acid, cefepime is high level resistance, so we really do not know whether there is AMC because it will be masked by class A, but there is no synergy, so we wouldn't know, and this synergy could be because of class A. Cefoxitin high level resistance, so it's not AMC, sorry, it's not ESBL. And even if it's ESBL, we wouldn't know because it will be masked by class A, which will hydrolyze cefoxitin very efficiently. Timoxylin probably high level resistance, so it could be oxa, but I don't know whether I can say for sure if it's an oxa because piptas is not that high of level resistant, so it is entirely not clear whether there is an oxa or not. There might be an oxa, but it might be masked by KPC or class A. So only thing I can say for sure is KPC here. Oxa may be present, but I wouldn't be able to confirm that. Even if it's there, it's probably masked by KPC. This one here, this one is essentially the same thing that I left, but you see there is only difference is, so let's go from the top. Amoxicillin, coamoxiclav, no difference, not ESBL. Piptas, low level, so it could be an ESBL, but not confirmed by coamoxiclav, so it could be a class A. Cefotaxime is 128 and there is synergy with clavulanic acid, so it could be a class A. It's not confirmed by coamoxiclav, so we don't think it's an ESBL, it's a class A again. There is not much synergy here. There is no cloxacillin synergy, probably not MC. There is again only one dilution, so it might be a synergy with clavulanic acid, but that because of class A. Timoxylin and those piptas is similar to previous one, so it could be an oxa which is masked by KPC. We are not sure. Artapenem 128, meropenem 32, so that could be because of an porine loss, so it could be class A with porine loss. And there is synergy with meropenem boronic acid, which is suggestive of class A. There is no synergy with imipenem DTA, so this is not class B. And this ceftolozane tazobactam, ceftazidime avibactam is confirming us that it is class A. So this is class A plus porine loss.